All right, first thing we'll do here on this checkpoint is put our name on there. And so today we're going to put our name, Sam the Turtle. Okay. And let's see here. We have a couple, like 4 systems of equations to solve, and we talked about using either the elimination method or substitution. So in number 1, this thing is like perfect for substitution. Check it out. Y, we know that y is the same as negative 2x plus 2. Boom. Anytime we see an equation that's solved for x or y all by itself, we want to take that and then we want to substitute that into the other equation for that variable. And remember to always put the substitution in parentheses. So let's make that substitution, and that's going to eliminate our y's, and we're going to have an equation with all x, which would be a lot easier to solve because there's going to be only one value that makes it true usually. So we have what, 5x plus 6 times, in parentheses, negative 2x plus 2. Okay, we made our substitution there, and then that's still equal to negative 9. Okay, now I got to go through and do some cleaning up. 5x plus, I guess it's actually plus a negative, so we'll just put minus because we don't want to be sign polluters. Minus 12x plus 12 equal to negative 9. Still cleaning this up, so you know you got your left side and your right side. If you have stuff to combine on the left side, let's combine it. So 5 and negative 12 combine to make negative 7x plus 12 equals negative 9. Put the 12 on the other side, you're going to get negative 7x is equal to negative 21, and so your x is positive 3. Okay, not done yet, because remember my solution is an ordered pair, so I know my x is negative 3, or positive 3, excuse me. Now I got to take that and I got to go and substitute that all the way back in for x, and I'm going to put it into the top equation because that makes a little more sense. So that one would be y equals negative 2 times whatever x is, which is 3, plus 2. So negative 2 times 3 is negative 6, plus 2 would be negative 4. So there you are, first answer, 3, negative 4. Number 2, not such a good system of equations for substitution because we'd have to solve one of them for x or y. And then we'd probably get some fractions in there that we don't really want to deal with, so we're just not going to do that. We're going to use the elimination method. And so we kind of look at our x's and our y's and we say, are they going to cancel out if we add them? Are they opposites? 3 and 2, no, they're not opposites. Negative 5 and 3, are those opposites? No, they're not opposites. Okay, well let's get a common factor, or not a common factor, a common multiple. Let's get a least common multiple of the x coefficients. So 3 and 2, that would be 6. That's not bad. 5 and 3, that would be 15. That's not quite as good as 6. So let's go with eliminating the x's and getting a common factor of 6 and negative 6. I keep saying factor, but I mean multiple. So there we go. We want to multiply this one by a 2. So take that top equation, multiply that all by 2. Take the bottom equation, multiply that all by negative 3. If I do that, then that's going to give me values that I can eliminate x with. So let's clean up that top one now. 2 times 3x is 6x minus 10y equals 2 if I multiply everything by 2. And then the bottom equation would be negative 6x minus 9y equals positive 36. Okay, this will be good because now I can take these 6x and negative 6x when I add, and they're going to eliminate. Negative 10y plus negative 9y is going to be negative 19y equal to 2 plus 36 is 38. Yay, it works out nice and neat. Yay, math book problems. Y equals negative 2. All right, am I done? Am I all done? I found y. I'm all done? Nope, you're not all done. Remember, your solution is an ordered pair. So you just found half of your ordered pair, the y value, negative 2. Now I got to find the x value. How do I find that x value? I take y equals negative 2 and I plug it into either one of these equations, whichever one's easier. I think the bottom one's a little easier. So let's do that. 2x plus 3 times negative 2 equals negative 12. Okay, clean that up a little bit. 2x, That's a -6. Move it over, it's positive. That's going to equal a -6 over there. So what did I do? I moved that over there. That was a -6, right? So I added 6 to both sides to get rid of it. And I find a y value of -3. Okay, so there you go on that one. You got a y value of -3, and you got an x value of -2. The bottom 2, 3, and 4 are a little bit of a special case going on. So let's see, when we go ahead and solve this bottom one, and you could really use either method to solve these. So you could use substitution or elimination. I'm just going to use elimination. That's what I tend to like to use. So I'll multiply the bottom one by -8. Okay, when I do that, I'm going to get -56x minus 8y equals +32. And then I go to eliminate those puppies. Remember, that's a negative. It's kind of hard to see this one over here. I'm going to erase that a little bit. That's a -56 there. Okay, so now when I go to eliminate, look at what happens. 56 plus -56, gone. 8 plus -8, gone. 32 plus -32, gone. Everything's gone. So I end up with just 0 equals 0. You know what that means when that happens? That means that the lines were actually the same lines. So what we're doing is we're actually trying to say, hey, when is this line going to be equal to itself? How many solutions? Well, you know, if you graph those lines, they would be like one right on top of each other. So the actual answer here is going to have infinite solutions. It's not all real numbers. Okay, a lot of people just think it's all real numbers. No, not any number works. All right, but it's going to have an infinite x and y values, an infinite amount of x and y values that make up solutions to that system. If we solve the other one over here, same kind of thing happens. Okay, I'll just show you. I'll show you substitution in this one here. So that bottom one I could rearrange and make it y equals -2x minus 6, like that. And then I could take that -2x minus 6 and I could put it in the other equation for y. So now I'm going to put that in there for y, and I'm going to have 6x plus 3 times, and instead of y I'll put -2x minus 6, and that's going to be equal to -12. Okay, clean that up a little bit. I have 6x minus 6x. That's interesting. And then minus 18 equals -12. Okay, these are going to cancel out. I see that. Watch that. Those are going to be 0. So now I'm left with -18 is equal to -12. What? What is that all about? What does that mean? Well, I'll tell you what that means. That means that those lines, if you graph them, are parallel lines. So if you graph those lines, however they look, that'd be like, if I made a little quick sketch of the graph, -2x minus 6, it's going to be like down here at -6 with a slope of -2. It's going to go like that. And then the other one is going to have some slope. I don't know where it is. I'm just going to draw on something. And these lines are actually going to be parallel. And so if they're parallel, they're never going to intersect. And if they never intersect, that means they're not going to have any possible solution that will work for those two lines. So that would be no solution. So there we go. They're solving systems of equations, including special cases, elimination, and substitution method. All right, bonsai.